Okay, welcome back everyone. Today we talk about the Antarctica ice sheet, and especially we are going to talk about the reason why we might just consider using simulation of the intrinsic random functions of order k in the sphere instead of using the Euclidean format of just statistical simulations when we process antimetry data measured in that region. And to help you, I'll try to make this hopefully short. So to help you understand, this is the the Antarctica sheet. It's, I'm not going to go into details about the ice sheet itself or uh, I mean the glaciology part of what I'm trying to explain today. But basically, this is in the South Pole, and the entire ice sheet, I think, lies below uh, the 80 degrees south, if I'm correct. Please, if I'm not correct, someone can just put the right number in the comment. But basically, we are right in the South Pole. The problem now is when you do geostatistical simulations, you think about understanding how the random function is changing in your sampling domain. So basically, it's like you consider, for example, two observations, and you look at the difference between those two observations, and you want to establish a relationship between how those are different from each other with respect to the distance between them, right? So now there is a problem, and it is the geometry of your space can have an impact on the term distance. So because of that, now you think, okay, I have the data and all that. And in that region, if you want to go from London to the UTM, so if you want to use UTM projection in that region, it's going to be difficult because the meridians are intersecting each other at the pole. The simplest way of explaining this is if you have a shape that is not too far from a square, you can readjust it so that it looks like a square. And in that square, now you can uh, geolocate your points, right? But when you have something like a triangle, it gets harder. To go from a triangle to a square, it is just harder than going from something which is not really a square, but like almost like a square if you squeeze it a little bit. So now you look at it, the way the problem is set up, the reprojection is tricky. Of course, you can spend time understanding how to make it so that you have a good reprojection, or you can just think about using simulations of intrinsic random function in the sphere, which is something already developed, ready for you to use, and it will be good for those who are working on the theory of it so that they can understand maybe they probably have limitation in terms of the theory, mathematical limitations. Maybe they do have, maybe not yet. But like realistically speaking, they will have mathematical limitations. However, those sometimes are different from the limitations that you will find when you bring the data side of the development. So you have the theory developed, now you want to apply it onto a data set. You might find some new limitations based on processing your data. So it will help the community as a whole to grow. And so I think, like I said, to keep it short, I think for regions like this, like in Antarctica, where projection can be kind of tricky, it might just be uh, easier to keep the long lat coordinate and use simulations in the sphere because we already have those in geostatistics. use them and move forward. You would save maybe 2 or 3 hours for some, or 2 3 days, or 2 3 weeks for some others, and move forward in your project. And I think it's a pretty elegant solution. So I don't know if I will spend time trying to find the right projection to process the entire ice sheet. Someone will say, oh, maybe I don't want to process the entire ice sheet, maybe just too much data to deal with. Thank God we have the computational power today to process that size of data. So I am pretty sure today some people like me are working on processing the entire data set, right? So the entire ice sheet. So if you're using simulation, just statistical simulations, I would say you don't need to worry about the projection anymore. If you didn't know, now you know. You don't have to worry about a projection. When you work on something that big, right? You can just use it on that. And instead of using simulation on the Euclidean space, you can use simulation in the sphere. So those functions are well developed, well documented. It's really easy to use. You just have to read, understand how you use it, and then the other part is just the interpretation. It will be the same, most likely the same trend. You know, as long as you understand how to use the method, then interpretation should just follow. So yeah, that's what I wanted to share with you today. Next time we talk about a reason why it's not. I might not say the same thing about Greenland because Greenland is another story. I don't think we have protection issues in Greenland compared to Antarctica. So, and I will also, after that, probably I would also talk about a special case where in Antarctica you can still use the traditional Euclidean simulations in geostatistics. So see you next time. Ciao.